in the dry heat of the Levant, where olive trees twist like ancient scripts and the wind still echoes through the stones of forgotten temples, something eternal lingers, not just in ruins, but in blood. Long before kingdoms fell, long before exile became the heartbeat of a people, a genetic lineage took root here. The land that cradled prophets, wars, covenants, and revolts also planted something deeper, something invisible, a thread spun into the cells of a wandering nation. Modern science, with all its cold instruments and silicon minds, stumbled onto a truth the Jewish people have carried in prayer and story for over 3,000 years, that their beginnings lie in this very soil. The genetic evidence is now undeniable. From Poland to Baghdad, New York to Casablanca, the DNA of Jews points in one direction, back to the Eastern Mediterranean. It aligns with the ancient Israelites, with Bronze Age farmers, with Chalcolithic tribes of the Zagros and Canaan. In genomes, we see the shadow of the first temples. Geneticists examining autosomal DNA, the full canvas of human inheritance, consistently find that Jews form a distinct cluster, one that is neither European nor purely Middle Eastern, but something ancient, anchored. The closer they look, the more precise the map becomes. Ashkenazi, Sephardi, Mizrahi, all fall within a genetic constellation pointing toward the Levant. Despite oceans and centuries between them, Jewish communities share segments of DNA too large, too identical, to be coincidence. It's as if history never truly cut them apart. It just drew the same story in different scripts. And that story begins in this land of stone and sun, the land of the Hebrews, where language was born from glyphs and lineage from tribes, where Abraham walked and kings reigned, and the Shema first echoed into desert night. Every modern Jewish genome carries markers that whisper this origin. They match with Palestinians, with Druze, with Bedouins, not because of confusion, but because all trace back to the same ancestral pool. The genetic tree doesn't lie. The Jewish people didn't just believe they came from this place. They actually did. But if all began in one place, how did the branches spread so wide, yet remain bound to the same root? That is the question history tried to bury, and science has begun to answer. They were scattered by sword and decree, not once, but across millennia. The destruction of the Second Temple, the rise of Rome, the fall of Spain, the silence of exile. From the banks of the Rhine to the hills of Kurdistan, Jewish communities began to emerge in isolation, separated by oceans, borders, and foreign tongues. But what no empire, no exile, no time could sever was the hidden continuity pulsing beneath it all. Genetic studies tell a story that history books can only hint at. Despite the global scattering of Jewish populations, their DNA remains intertwined, braided like the threads of a single talith pulled across continents. Jews of Eastern Europe, North Africa, the Middle East, even those who lived for centuries without contact, reveal levels of genetic similarity that astonish even the most seasoned population geneticists. How can a Jew from Lithuania, raised in the snowbound towns of the Pale, be more closely related to a Moroccan Jew from the sunburned walls of Fez than to their non-Jewish neighbors? The answer lies in the resilience of bloodlines. Autosomal DNA studies show that, despite long periods of isolation, Jews across the world maintained what scientists call a shared Middle Eastern core. Their genetic signatures cluster in ways that mark them as not only related, but descended from the same ancestral stock. When researchers mapped Jewish genomes onto global population datasets, they saw something rare, a distinct and tight grouping that resisted full assimilation into the genetics of their host countries. Ashkenazi Jews, for example, do not fully overlap with Slavic or Germanic populations. Instead, they form a genetic midpoint between Middle Easterners and Southern Europeans, reflecting an ancestral path from the Levant, through Rome, into Central Europe. Similarly, Sephardi Jews, who lived for centuries in the Iberian Peninsula, retained enough ancestral continuity that even after expulsion, their descendants in North Africa and the Ottoman Empire carried unmistakable Levantine signals in their DNA. It's as if the diaspora didn't dilute the Jewish genome, it refined it, like a sacred scroll rewritten across generations, slightly altered by geography, yet holding the same sacred message at its core. While local admixture occurred, some Italian, Iberian, North African, or Slavic traces. It never erased the foundation. In fact, the amount of gene flow from host populations into Jewish communities was remarkably low, given how long Jews lived among them. Endogamy, driven by religion, law, and survival, acted as a cultural insulator, preserving genetic identity while the world around them changed. Even more remarkable is the genetic closeness between Jewish populations who had no opportunity to intermix. Syrian Jews and Ashkenazi Jews, Iranian Jews and Sephardi Jews. The genetic distances between these groups are smaller than between Jews and their Gentile neighbors. This is not expected. This is not random. This is the footprint of an unbroken thread, a people dispersed, but not dissolved. The Jewish genome is not a patchwork of wherever Jews happen to land. It is a layered manuscript of migration, yes, but always tethered to its origin. The diaspora, in all its heartbreak and adaptation, could not erase the signal. The blood never forgot where it came from. There are moments when history doesn't just bruise a people, it compresses them. It shrinks their numbers to the brink. It drives them into corners of survival, so tight that their very genetics come out changed. For the Jewish people, these moments weren't rare. They were rhythmic, a cycle of devastation and rebirth, each time reshaping the genetic legacy left behind. Population bottlenecks, in genetic terms, are sudden contractions in group size, followed by expansion. In human terms, they are massacres, expulsions, famines, forced conversions, disease. And in the Jewish experience, they occurred across centuries and continents. Each time a community was reduced to a fraction of its size, the future was built from the DNA of a few. A handful of survivors became the ancestors of thousands. The Ashkenazi population is perhaps the most extreme example. Genetic models suggest that their lineage passed through a near-genetic bottleneck around the 10th century. Possibly as few as 350 individuals carried forward the bulk of today's Ashkenazi genome. The evidence is in the data. Modern Ashkenazi Jews share extended stretches of DNA, far longer and more frequent than in other populations. These are not just distant genetic cousins. They are, in many ways, the descendants of a single village, multiplied into millions. But bottlenecks weren't exclusive to Europe. When the Jews of Spain were expelled in 1492, entire communities scattered into fragmented enclaves. Some fled to Morocco, others to the Ottoman Balkans, some to Italy or the Levant. Each refuge formed a miniature founder population, small, isolated, intermarrying, and in doing so, baked specific mutations and genetic traits into their descendants. The loss was cultural, spiritual, architectural, but it was also biological. And then came the greatest rupture of all, the Holocaust. Over 6 million murdered, entire bloodlines erased in a few short years. This wasn't just a tragedy of the 20th century. It was a genetic shockwave. Entire haplotypes were lost. Mitochondrial lineages vanished. For some Jewish subgroups, entire maternal branches were extinguished, leaving future generations with only a partial record of what once was. Founder effects, born out of these bottlenecks, left a paradoxical legacy. On one hand, they preserved the ancient core. On the other, they amplified rare mutations to levels unseen in other populations. Diseases that are globally rare, like Tay-Sachs or familial dysautonomia, became concentrated, not because of divine curse, but because of mathematical inheritance from a small surviving pool. In the Middle East, Mizrahi communities experienced different, quieter bottlenecks. Long-term geopolitical instability, conversion pressures, and economic marginalization pruned their populations slowly over generations. Each wave of immigration, each episode of violence, whittled down diversity, until a handful of family lines carried forward the entire memory of Babylonian Jewry or Persian exile. What these genetic earthquakes reveal is not fragility, but resilience. After each collapse, the community regrew. It rebuilt not only its homes and synagogues, but its future generations from fragments. It's why modern Jewish DNA is so distinctive. Not because it is untouched, but because it is shaped, carved by the hand of history into something specific, traceable, and in a way sacred. Across centuries and continents, 3 branches of a single ancestral tree began to grow in different directions. Shaped by foreign lands, local customs, and shifting empires, they came to speak different languages, wear different garments, sing different songs. But beneath those differences, something deeper persisted: the genome, a coded memory that held them together long after maps and borders tried to pull them apart. The Ashkenazi Jews emerged in the shadows of medieval Europe, first in the Rhineland, then eastward into the forests and ghettos of Poland, Lithuania, Ukraine. Their isolation was not chosen, but enforced. It became genetic as much as cultural. Modern studies show they carry a mosaic of ancestry, some from ancient Israel, some from early southern European admixture, likely absorbed during the Roman era. But once the gate closed around them, their gene pool became one of the most studied and tightly defined in modern science. Whole communities descended from a small number of founders, their genetic code sharpened by centuries of endogamy and rapid population growth. Sephardi Jews traced their path along warmer coasts, through the Iberian Peninsula, under the caliphates of Al-Andalus. They were philosophers, merchants, poets. Until 1492, the Edict of Expulsion turned flourishing cities into points of rupture. As families fled to North Africa, the Ottoman Empire, and beyond, they carried with them more than just memory. They carried a genetic imprint. In their genomes, we see traces of Iberian and Berber interaction, layered on top of a strong Levantine foundation. Communities from Salonika to Fez reflect a deep but distinct connection to the original ancestral pool, tinged with the geography of their exile. Mizrahi Jews are the keepers of continuity. They never left the broad region of their origin. From Baghdad to Tehran, Sana'a to Aleppo, they remained rooted in the very soil where ancient Israel once rose. Their genetic profiles are often closest to the ancestral signature, less shaped by European or North African admixture, more aligned with neighboring Semitic populations. Yet even among them, isolation forged its own genetic paths. Iraqi and Iranian Jews, for instance, cluster closely with one another, sharing ancestry with ancient Mesopotamian Jews who lived under Persian and later Islamic rule. Yemenite Jews stand apart even further, showing hints of interaction with local Arabian lineages, yet still unmistakably Jewish in genetic signature. Each of these groups is not simply a reflection of their geography. They are echoes of both homeland and history. What unites them is not the uniformity of DNA, but the continuity of it. From the crowded shtetls of Eastern Europe to the sun-baked towns of the Maghreb and the old synagogues of Shiraz, Jewish DNA tells a story of preservation through dispersion. They are not copies of one another. They are variants on a theme. 3 distinct symphonies, composed in different climates, but all playing in the key of origin. There is a lineage that has outlasted monarchies, migrations, and massacres, a father-to-son thread that winds unbroken through over 100 generations. It does not live in books or monuments. It lives in a molecule, one passed only through men, the Y chromosome. Among Jewish men who claim descent from the ancient priestly caste, the Kohanim, there is a remarkable genetic echo. Long before anyone knew what DNA was, they preserved an identity that modern science would one day verify in code. Geneticists, searching for patterns, found one: a cluster of nearly identical Y-DNA signatures spread across Jewish populations from vastly different regions. Whether in Tunis or Vilnius, Baghdad or Brooklyn, a specific genetic motif kept appearing in men who carried the title Cohen. This signature came to be known as the Cohen modal haplotype, a series of genetic markers most commonly found in the J1 lineage, specifically in the subbranch J, P58. It isn't found in all Jewish men. It isn't even found in all who claim priestly ancestry. But its frequency among self-identified Kohanim is too high, too globally consistent, to be a coincidence. It suggests a single paternal ancestor, possibly over 3,000 years ago, whose descendants preserved not only a name but a strand of code. Unlike autosomal DNA, which blends with every generation, the Y chromosome remains nearly unchanged as it passes down the male line. Mutations occur slowly. That makes it a time capsule, one that speaks across ages. And in the case of the Jewish priesthood, it speaks of astonishing continuity. A fragment of Aaron, perhaps, surviving through exile and return, through whispered blessings and buried names. But the mystery deepens. the same Y signature, or close variants of it, appear in multiple Jewish communities that had been separated for centuries. Ashkenazi and Sephardi Kohanim show overlap. Mizrahi groups, particularly those from Iraq and Iran, also reflect the same lineage. How could this be? Unless the tradition of priestly descent had a real biological root. Genetic research doesn't claim to prove theology, but what it does confirm is that oral memory can be startlingly accurate. A name passed down through ritual and responsibility may, in this case, align with a very real ancestral thread. The priesthood wasn't just symbolic. It may have been, at least in part, hereditary and remarkably preserved. Even among secular scientists, this pattern commands respect. In a world where surnames fade and family trees blur, the Jewish Kohanim have maintained not only identity but genetic traceability. It's one of the few cases in population genetics where genealogical tradition and genetic data converge so tightly. This is not just about one haplotype. It is about the idea that within a scattered people, some lineages held their shape. Despite conquest, despite erasure, despite all attempts to sever continuity, a single Y chromosome still whispers, "I remember." If the Y chromosome speaks with the voice of ancient patriarchs, then mitochondrial DNA whispers through the centuries with the breath of mothers, unbroken, uninterrupted, passed from mother to child. It carries no fanfare, no title like Cohen. But in many ways, it tells a story just as profound, and often more surprising. In the case of Ashkenazi Jews, this maternal record holds an unexpected truth. Genetic studies have revealed that a significant portion of Ashkenazi mitochondrial lineages, nearly 40%, trace back not to the Middle East, but to 4 women who lived roughly 1,000 years ago. These women, whose names are lost to time, are believed to have lived somewhere in Europe. Yet their genetic legacy pulses through millions today. These aren't vague statistical inferences. They are specific mitochondrial haplogroups, including K1A1B1A, K1A9, N1B, and K2A2A, found in high concentration among Ashkenazi Jews and almost absent from other populations. The implication is staggering, that a large proportion of the modern Ashkenazi maternal line descends from a very small number of ancestral women. They became, quite literally, founding mothers of a people reborn in exile. But who were they? Were they converts, locals who married into Jewish communities during early medieval expansion? Or were they Jewish women whose lineages had already diverged from known Middle Eastern roots? The genetic data cannot answer these questions fully. Yet the presence of these lineages, isolated, distinctive, and dominant, tells us that female ancestry was not just a passenger in Jewish history. It was a driver of identity, survival, and genetic direction. What makes mitochondrial DNA so hauntingly powerful is its persistence. Unlike other forms of inheritance, it passes unchanged from mothers to daughters, generation after generation. There's no mixing, no dilution. It is, in effect, a perfect memory. And in this case, it reveals that Jewish identity was preserved not only through books and blessings, but through the silent continuity of women, raising families in times of threat, carrying culture as well as genes. Outside the Ashkenazi world, other Jewish communities also show signs of localized maternal influence. Mizrahi and Sephardi Jews tend to carry mitochondrial haplogroups that align more closely with their regions of origin. Iranian Jews, for instance, show haplotypes consistent with ancient Persian maternal ancestry. Yemenite Jews bear signals of Arabian maternal influence, likely reflecting centuries of rooted presence in the southern Arabian Peninsula. Yet across these communities, something unites them. The maternal lines, though regionally shaped, still nest within the broader Jewish genomic architecture. This maternal diversity doesn't dilute the Jewish genetic story, it completes it. While paternal lineages trace ancient tribal cohesion, the maternal line shows adaptation, resilience, and unexpected inclusion. It reminds us that identity isn't always passed down by decree. Sometimes it's carried in the body, nurtured in the home, and preserved in the quiet act of surviving one more generation. The women who shaped this legacy remain nameless in history, but their legacy is undeniable in science. Their DNA, hidden for centuries, now rises from the depths of the genome like a lost melody, proof that Jewish continuity was not only defended in synagogues and scrolls, but carried in wombs, over borders, through fire and silence. In certain families, pain travels quietly. It doesn't speak until the child is born. It waits, in the blood, in the code, in a mutation passed down unknowingly for generations. But in some populations, that pain isn't random. It's historical. It's structural. It's embedded in the architecture of inheritance. And nowhere is this more tragically visible than in the genetics of the Jewish people. For many Ashkenazi Jews, the legacy of survival came with a hidden cost. Within their DNA lie mutations that rarely appear in the broader human population, but among their own, they are disproportionately common. Disorders like Tay-Sachs, Gaucher disease, familial dysautonomia, and BRCA-linked cancers haunt the community not as ancient myths, but as statistical realities. These are not cultural traits. They are biological scars, left behind by the narrowing funnels of history. Centuries of isolation, whether enforced by pogroms or chosen through cultural boundaries, reduced genetic variation. When small populations rebuild after trauma, the gene pool is limited. If a mutation is present among the survivors, it has nowhere to hide. It becomes amplified, and what was once rare becomes inherited. Tay-Sachs, perhaps the most well-known of these conditions, is a devastating neurodegenerative disease. Among Ashkenazi Jews, approximately 1 in 27 carries the gene. Gaucher disease, which affects lipid storage, has a carrier rate nearing 1 in 10. These numbers are not chance. They are the genetic consequences of repeated historical collapse and the stubborn will to rebuild. But this pattern isn't confined to Eastern Europe. Other Jewish groups have their own echoes of this phenomenon. Sephardi Jews from North Africa, particularly Moroccan and Libyan communities, show elevated risks for certain metabolic conditions. Among Mizrahi Jews, especially those with Middle Eastern ancestry, disorders like familial Mediterranean fever appear with unusual frequency. Even rarer communities, like the Bene Israel of India or Bukharan Jews of Central Asia, carry distinct hereditary traits, shaped by centuries of local adaptation and internal marriage. These inherited risks paint a sobering picture, but they also highlight one of the most powerful success stories in modern medicine. Beginning in the late 20th century, Jewish communities initiated proactive genetic screening programs. Couples began testing before marriage. Families confronted their own histories not with shame, but with science. As a result, diseases that once devastated generations, like Tay-Sachs, have seen a dramatic decline in birth prevalence. This is not just genetic management, it's cultural evolution. A people long defined by exile and continuity turned their attention inward, using science to protect what history so often tried to erase. They turned DNA from a source of sorrow into a tool of preservation. But the deeper message lies in the patterns themselves. These diseases are not just random errors in replication. They are biological reflections of historical suffering, the bottlenecks, the ghettos, the expulsions. The trauma wasn't just written in memory. It was encoded. Jewish DNA does not carry these mutations because of weakness. It carries them because it survived, again and again, through impossibly narrow gates. And what remains today is not just the genetic cost of endurance, but the map of how endurance took place. What separates one people from another? Geography, religion, language. Sometimes the borders that seem so permanent on maps are nearly invisible in the genome. And when scientists looked closely at the DNA of Jewish populations, they discovered something unexpected. Not isolation, but proximity. A closeness not to the nations Jews lived among for centuries, but to those they had once lived alongside before exile began. Across the Near East, the genes of ancient peoples remain buried in modern bodies. And among them, Jews, Palestinians, Druze, and Bedouins all carry echoes of the same deep ancestry. Genetic analysis reveals that these groups are not distant strangers, but relatives, distinct branches of an ancient regional tree, each shaped by their own stories, but rooted in shared soil. The connection is clearest in the paternal line. Y chromosome studies have shown overlapping haplogroups, particularly J1 and J2, across many Semitic populations. These are not generic signatures. They are genetic footprints of ancient Levantine heritage, passed down through thousands of years, unshaken by empire or migration. And within those patterns, Jewish men often cluster more closely with their regional neighbors than with distant co-religionists in the diaspora. But similarity doesn't mean sameness. The difference lies in the structure of continuity. While other populations absorb layer upon layer of genetic input from new migrations, Arab tribal expansions, European crusaders, Turkic waves, Jewish communities, though not untouched, remain comparatively insulated. Their endogamy acted like a time capsule, preserving older genetic layers that elsewhere were overwritten. This is why genetic distance often surprises historians. A Jewish family in Ukraine may be more closely linked, genetically, to a family in northern Iraq than to their Slavic neighbors. A Mizrahi Jew from Tehran may share more with a Sephardi Jew from Izmir than with the Muslim populations just beyond their city walls. This isn't folklore. It's embedded in the genome, evidence that shared origin can endure long after physical connection has faded. And yet, the relationship with neighboring groups isn't erased. It's complicated. Some Jewish populations do carry traces of local admixture, Southern European components in Ashkenazim, North African influences in Maghrebi Jews, Arabian markers in Yemeni lineages. But these are precisely that traces, additions to a larger, older signature that remains remarkably coherent across time and space. One study even identified a small percentage, roughly 3 to 5%, of sub-Saharan African ancestry in many Jewish groups, a signal also found in some Southern Europeans and Near Easterners. But in Jewish populations, the signal appeared older, suggesting it entered the gene pool before diaspora fragmentation, possibly in the ancient Levant, long before the scattering began. In this way, Jewish genetics reflects a paradox. It is globally dispersed and yet genetically cohesive, distinct from neighboring non-Jews, yet connected to ancient regional cousins, not sealed off from history, but not dissolved into it either. Jews did not carry exclusive genes. What makes their DNA unique is the arrangement, the concentration, and the preservation of certain markers over time. They are part of a broader Middle Eastern genetic continuum, but as a singular thread within that tapestry, they tell a story that belongs both to the region and to themselves. Genetics can reveal where we come from, but not why we remember. It can trace lines through millennia, decode the migrations of ancestors, measure proximity between strangers. But what it cannot do is explain why a people endure, not just in cells, but in soul. Jewish DNA is unique, yes. It has structure, continuity, and signatures that point across centuries to the ancient Near East. But that uniqueness does not tell the full story, because who a people are is never written in molecules alone. There is no sequence in the human genome that explains why Jews lit candles in secret during inquisitions, or whispered prayers behind iron bars. No allele accounts for the resilience of a culture that rebuilt itself after every fall, or the decision to teach children an ancient language in lands where it was outlawed. These are not functions of inheritance. They are choices, acts of will, of tradition, of meaning. A person can carry every genetic marker of a group and still not belong to it in spirit, and another can carry none and live its legacy. That is the boundary of biology, where history, law, faith, and memory begin. And for the Jewish people, those forces were never separate from identity. They were its scaffolding. The genome offers clarity, but not definition. It can map ancestry with stunning precision, connect people across oceans, reveal lost lineages, but it cannot define belief or explain belonging. Jewishness has survived not because of genes, but because of remembrance. Through liturgy, through ritual, through exile and return, through a refusal to let time wash away the past. Yes, there are no Jewish genes in the way some imagine, no single mutation that marks someone as chosen or set apart. Instead, there is a constellation of inherited patterns, shaped by migrations, by bottlenecks, by love and fear, and the simple mathematics of who survived. These patterns can be measured, but not lived. Not fully. To be Jewish is to carry something more than DNA. It is to carry memory. And memory is not bound by biology. Science, for all its reach, stands at the edge of that mystery. It can touch the echoes of ancient tribes, trace lines back to the hills of Judea, map the distance between cousins separated by continents, but it cannot answer the final question. How did they remain a people when everything conspired to scatter them? That answer lies not in code, but in conviction, not in genomes, but in generations who chose to stay connected, to faith, to story, to one another. And so, as the study of Jewish genetics continues to expand, it must be understood not as a definition, but as a mirror, one that reflects history, yes, but also perseverance. It shows us how far they traveled. It cannot explain why they never forgot the way home,